Okay, now so far we've seen a few of the main features of Spark. So the first thing that we talked about is that with Spark, we're mainly operating in memory, right? The data is being saved to memory and not to disk. And one of the benefits of that we talked about was this ELT pattern, where we do not have to first create tables before loading in and reading in our data. And the other thing about that is that, well, while the data is saved in memory while we're analyzing it, for long-term storage, we're really saving it externally in something like Amazon S3. And we said this long-term storage externally and outside of the cluster, this saves us a lot of money. It allows us to store data that we're not quite sure how we might want to use it, but because it's so cheap, we can simply store this low or unknown value data. A second thing we saw about Spark was just how fast it is. And the reason why it's fast is because it's distributed. So we read in our data and we partition it, and then as we know, we can perform queries across our data set in parallel, right? Across these partitions in parallel. And that's that RDD, right? The resilient distributed data set. And then the last thing we saw is that Spark is delaying execution, right? So we talked about the differences between transformations and actions, and that actions are the things that actually perform the work, and that by the time we get to an action, Spark can kind of see, okay, does it really need to transform all of these records when at the end of the day, you're only going to be maybe asking for to see a single one of them. All right, so Spark can be efficient in terms of the amount of work it does and really only do the minimal amount of work necessary to return you the results that you're asking for. One other thing we should talk about is Spark, how Spark achieves resiliency. So, databases and distributed databases, the intent is that they should be fault tolerant. And what does that mean? That means that even if, say, one of these nodes goes down, where the data is being stored, we want some way to be able to recover that data, right? Computers can go down, and when they go down, the most important thing on that is going to be your data. So we don't want all that data just to be lost. Now, normally, the approach to achieving fault tolerance, right, that's what I put here, with most databases would be simply to copy the data. So this way, if one node goes down, we still have the data stored in a second node, and we'll be okay. Now, this approach of copying the data has a couple of issues to it. One is you can just guess, right? It takes up space, right? It's double the amount of space. The other issue is copying the data from one node to another takes time, because this pipe, this bandwidth, right, is oftentimes narrow between the nodes. So then moving data from one node to the other, right, takes time. And we saw that, by the way, with that same idea when we talked about shuffling. So instead of just creating a second node, Spark doesn't do this. Spark takes a different approach. What Spark does is it keeps track of all the transformations that occur. So you read in the data, right? And then let's say we capitalize all the movies. And so we have a subset of the capitalized movies on this node. If this node goes down, Spark will keep track of, okay, we had these capitalized movies by reading it in and then performing some sort of transformation, and that's how I got to here. So if this node goes down, Spark will just reapply those steps. So let's see that. We can kind of get evidence of it. And right here, we will create again my Spark context. And then let's open this thing up. I'll type in SC. And now we can get to this Spark UI. It was this one. And you can see I'm not running any Spark jobs at this point. So then I will create a distributed data set by taking a normal Python list and calling this parallelize method. And then we can, I just want to create a job, right? So what am I doing? I'm looking for the movie Dunkirk, and then I'm capitalizing each of those movies. Let's let's say we're at movie 0 equals D. We'll just find all movies with D and then capitalize them and then show the results. And it doesn't work because the list object, this should be movies RDD, right? I want to apply this to my resilient distributed data set, not to the ordinary list. So it's performing the task, and then we can see the capitalize method just returns the first letter, or capitalizes the first letter in a string. Then let's go over here, we'll refresh. We can see here's my job that was completed. Let's click on this job. And if we click on this, you can see it says DAG visualization. So DAG stands for directed acyclic graph. I don't think I want to get into too big of a detailed definition of what that means, but this is an example of it. You can see it has an arrow, right, from one direction to the next, and the other thing is that it does not loop, okay? So that's where the acyclic comes from, is the fact that it just doesn't loop back and keep going. And the directed part is there is a workflow, right? It's starting here and it's going down here. So what you can see here is that it is saying parallel collection RDD, read from the file, and then call collect. And if you think about what happened, right, we are reading from the file, that's really this list here, and then create the parallel collection, that's this step here, and then finally it's applying this filter and map transformations and then collect. So if a node went down, it would simply reapply these steps, okay, for that relevant data where that was lost. So if we lost all the records in here, it would be like, okay, well, how do we do this? Well, we read in the data, and then we reapplied, we filtered and mapped, and so it would just reperform these steps, and because it has a log of them, right, because it knows those steps, it's able to reapply them. So that is how Spark achieves fault tolerance. One consequence of Spark keeping track of every single step that is applied in the DAGs is that it only allows certain kinds of transformations. So it allows what we call course transformations. What are course transformations? Well, think about like a normal list. If say we wanted to capitalize an element in the list in Python, we can maybe select the second element and then capitalize it, right? And we can just operate on a single element in the list. In Spark, you cannot operate on just a single element. You can only apply your changes and transformations to the entire collection, right? So this makes it a little easier to keep track of the different steps because we're applying it to the entire data set. We're not pick and choosing based on an individual piece of data. So say that you did only want to apply a step on a specific piece of data. What you would do is, so we have our movies RDD. Just take a look at it by doing movies RDD.collect. So this is an action. So we have these things. And if say you just want to capitalize the movie Dunkirk, well, what you would do is first filter, go through all the movies, that is Dunkirk, and then map through that set of movies. Now that we've basically just selected Dunkirk, and then capitalize that movie. And then we can call collect on it. This is called title, I guess. All right. So if you want to just select or apply a change to just one movie, because Spark only allows for course transformations, you would need to essentially just filter through, find that movie. This will return a list of those matching movies, which is Dunkirk, and then from there you can capitalize it. So that's one consequence, is that only of Spark keeping track of each of the steps that are applied, is that it's only allowing for course transformations. And again, we can kind of take a look at this, reading from it, calling this collect. The other consequence is that each of these transformations is not affecting the previous data set. So it's not affecting the previous RDD. Rather, it is creating a new RDD from the original. So what I mean is, we start with an RDD of this list of movies. Then we filter. This, I'm assuming, creates a new RDD, Dunkirk. And then from here, we are capitalizing. So this capitalization is not going to change the previous RDD. Rather, it will create a new RDD from that. This way, the reason for doing something like this is so if you ever want to go back and I guess use this piece of data, it's unchanged. You can use it. You can rely upon the fact that it has not been altered by any other transformations down the line. So you can see that again in the DAG here, where we are creating an RDD here. And look, here's another now Python RDD. So it's creating a different RDD each time. So whenever you apply these transformations, right, it's going to not affect the original RDD that you're reading in, but rather create a new RDD from that original.